In this session, we will solve numericals on parallel operation. The first problem is a load sharing between the two transformers with equal voltage ratio. That is, two single phase transformers with equal voltage ratio have impedance of 0.819 plus J2.503 ohm, and the second transformer has got an impedance of zero point 0.8 plus J2.3 ohm with respect to the secondary side. If they operate in parallel, how they will share the total load of 200 kilowatt at a power factor of 0.8 lagging. Before solving this problem, just you have to note on the what are the data, different data is given. That is ZA is given, that is we are writing here. Either you can put it in the same form, you keep as it is, that is in the rectangle form, or you can convert if you want for your convenience, you can convert into the polar form. There is no necessity of converting. If you want, you can do it. And ZB also got to express in both rectangle as well as polar form. Then in the equation we need ZA plus ZB also. Therefore, I am putting ZA and ZB in the both rectangular and the polar form. Then load what is given is 2000 kilowatt at a power factor of 0.8 lagging. Then what is the kVA of the transformer or kVA output of the two transformer? kVA output of the two transformer, that is the actual load kVA. How we are finding out kVA? That is kilowatt divided by cos phi. Therefore, it is 2000 divided by zero point 0.8. That is what our getting is 2500 kVA is the total load with a power factor of zero point 0.8 lagging. Therefore, the total load can be expressed in terms of kVA as 2500 an angle of minus 36.87. Okay. Now the load shared by the transformer A, it is a expression is S into ZB divided ZA plus. Everything is there. Just you have to substitute the value of S, ZB, ZA and ZB. S is already given here. Therefore, I am putting S here and ZB and ZA I am putting directly from the polar form. You can put it in the rectangle form also. Then you can make use of your calculator, calculate the value of SEA. SEA what I am getting is 1203.7 an angle of minus 33.37 kVA. Then if you want to express this in terms of kilowatt, then what you have to do is for kVA you have to multiply cos of 37.37. That is a load of 1203.7 cos of 37.37 is nothing but the load shared by the transformer A with 956.6 kilowatt at a power factor of 0.79 power factor line. This 0.79 we are getting cos of 37.37 is nothing but 0.7. This is how to solve the problem for SA. Similarly, you can what is the load shared by the transformer B, that is SB is equal to S into ZA divided by ZA. Once again, you have got all the data, just you have to substitute, then you have to find out what is the value of SB. SB you are getting 1296.93 with an angle of minus 36.39. Then once again you convert that into the kilowatt, what you are getting is 1443.5 kilowatt at a power factor of 0.805 power factor lagging. You are getting the answer. Next problem, once again it is from the question paper, and it is on equal voltage ratio. Two single phase transformer with equal voltage ratio is given the load in terms of kVA itself, 400 kVA at a power factor of 0.8 lakh. Directly is given in the terms of kVA. Their equivalent impedance referred to the secondary windings is given in terms of 1 plus J2.5 and 1.5 plus J3 respectively. Calculate the load shared by each transformer. Once again, the procedure is same. That is, you have to list out ZA and ZB. I am keeping as it is ZA and ZB. And ZA plus ZB I am adding here. What I am getting here is a 2.5 plus J 5.5 ohm. And total load is given 400 kVA and at the power factor of 0.8 lakh. Therefore, I am expressing S as 400 an angle of 36.87 kVA. Then once again I am making use of the formula SA is equal to S into ZB divided ZA plus ZB. Just S is this value, ZB are what is here, ZA is here, and you have to substitute in this equation. That is 400 an angle of 36.87, it's a degree, and kVA into 1.53 plus J3 2.5 plus J5.5. Just you have to enter in your calculator. Then what I am getting here is 222.07 an angle of 38.99 kVA is the load shared by the transformer A. And if you are expressing in terms of kilowatt, just you have to take 222 cos of 38.99, that is comes out to be 171 kilowatt at a 0.77 power factor lagging. Similarly, you calculate the load shared by the transformer B, that is SB is S into ZA divided by ZA plus ZB. Here I have got a S value I am substituting here. It is 36.87 degrees, and it is in terms of kVA into ZA, that is 1 plus J2.5 divided by ZA plus ZB, that is total value I have got 2.5 plus J5.5. You have to substitute, and you have to, from the calculator you have to calculate SB. What I am getting here is 178.27 an angle of minus 34.227 kVA. It is a load shared by the transformer B. Then if you want to, once again, if you want to express this, the load in terms of kilowatt, then you have to take the 178.27 cos of 34.227, that is what you are getting is in terms of kilowatt. Therefore, kilowatt shared by the transformer B is 147.4 kilowatt at a power factor of 0.8 to 68 power factor lagging. It is a load shared by the transformer. It is a load shared by the transformer B. This is how you have to solve the problem. Okay. Then one more check you can make it. It is a 400 kVA at a power factor 0.8. The total load is, it is 320 kilowatt. 400 into cos of 5, that is 320 kilowatt. If you are adding these two, you are getting 320. This is how you have to check the answer also at the same time. Okay. The third numerical is the two transformer A and B. It is on unequal voltage ratio. 500 kVA and 250 kVA are supplying a load of 750 kVA at a 0.8 power factor lagging. Their open circuit voltages are 405 and 415 volts. He is given EA and EB. Transformer A has some impedance, that is 0.0032 ohm, and its reactance is 0.016, and B has got 0.0096 ohm resistance and 0.0256 ohm reactance. What he asks you to calculate is, here is circulating current at no load, the load current shared by each transformer, that is I and IB, kVA, that is kVA shared by the transformer A and B, and at what power factor these two transformers they are operating. These are the questions asked. The simple thing is, go by the what he asked. First you have to list out the data given here systematically. That is, take the voltage across the load. It is another data is given as a 400, that is VL 400, that is voltage across the load is given. Just you have to list out the data. ZA is given, then ZB is also given, ZA plus ZB I am calculating here by adding these two. Next, the load is given 750 kVA at 0.8 power factor lagging, that is also 750 kVA at 0.8 power factor lagging, that is given. Then the terminal voltage at operating is VL is also given as 400 volts here. Then load impedance you have to calculate, because in I and IB equation you come across load impedance. Then how to find out the load impedance? The load impedance can be calculated as load voltage square divided by volt ampere at the load terminals. Load voltage is voltage across the load is 400 volts, and the volt ampere at the load point is 750 kilovolt ampere. Therefore, I am substituting here, that is 400 square the voltage, terminal voltage, divided by 750 into 10 raised to 3, because it is 750 kVA that I am converting into 10 raised to 3. But here, at what power factor it is operating? It is 0.8 power factor lagging. Therefore, I am taking minus 36.9. You should not forget about the load at which power factor it is operating. Therefore, you can calculate ZL as 0.214 an angle of 36.9 ohm. That is, it is in the denominator. When if we are dividing this, it will come in the numerator. Then it is becomes plus, that is 36.9 degree. That is, you are getting ZL. You are getting all the data ZA, ZB and ZL. Then first here what he asked is circulating current. The circuit current formula is, it is IC is equal to EA minus EB divided by ZA plus ZB. That is what I am putting here. Circulating current at no load is IC is equal to EA minus EB divided by ZA plus ZB. Therefore, we can straight away substitute, means he is not mentioned anything about the phase angle of A and EB, that default you have to take it as 0. Therefore, if EA angle of 0 degree means it is a EA only. Therefore, I am directly substituting here, it is 400 minus 450 divided by ZA and ZB, ZA plus ZB, it is already there, that is 0.0436 an angle of 72.9 degree, that I am substituting here. Then after the calculations, what I am getting is, if the two transformers are not connected to load because of unequal voltage ratio, there is a circulating current between the two transformers. The magnitude of that current what I am getting is 229.35 with an angle of minus 72.9 degree amperes. Here the current is flowing from B to A because the B has got the higher voltage than the A. Therefore, the current will flow from B to A. This is how we have to calculate the circulating current. Only thing is listing out the data and properly calculating the value of ZL. ZL if the load is given. Okay. Now, the next what he is asking is load current shared by each transformer. That is IA and IB. Then how we are finding out. We are listing out once again the data given. Once again, I am taking our fresh data here from the previous slide. That is ZA, ZB and ZL. Then I have to calculate IA. This is EA, ZB, EA minus EB, ZL. This is the equation what I am getting. Then you have to list out the data. ZA, ZB and ZL are there. Then what about EA and EB? That is, also I have to calculate IB. However, my EA is 405 and angle of 0 degree. EB is 459 angle of 0 degree. Because he is not mentioning anything about the angle, just default I am taking that as a 0 degree. Now I have got the load shared by the current A, transformer A and B. Then in this equation I am substituting the value of all EA, ZB, ZA, ZB, all these things. After substituting this value, either you can put in the polar form or you can put in the rectangular form. It does not matter. The answer is the same. Therefore, what I am getting here is, after substituting all these values, what I am getting here is I is 936 an angle of minus 35.2 degree amperes is the current shared by the transformer A. Similarly, you have to make use of this formula, put the value of EB, ZA and all the parameters in this equation. These all the parameters are available, and if we are simplifying, then what I am getting is IB is directly I am putting here, that is 878 an angle of 42.2 degree amperes. This is a current supplied by the transformer B. Then the third part what he is asking is, what is the load shared by the transformer A and B? The load shared is expressed in terms of volt amperes. It is nothing but the terminal voltage multiplied by the respective current which is delivered by each transformer. Therefore, What I am putting here is SA, that is a load saved by the transformer A, is VL into IA into 10 raised to minus 3. VL is 400 is given, IA is already there, that is 936. Therefore, 400 into 936, what I am getting, you can express in terms of kVA, that is you have to multiply 10 raised to 3. That is another 10 raised to 3 you have to, it is a 10 raised to 3 you have to multiply here, 10 raised to minus 3. 10 raised to minus 3 you have to make it, it is already written in this equation, there is a mistake here. Then what I am getting is 385 kilowatt amperes. Similarly, the SB is equal to VL into IB into 10 raised to minus 3. What I am getting is 400 into 878, and also you have to take the 10 raised to minus 3. That is once again that is you have to multiply your 10 raised to 3 here and 10 raised to 3 here, so that you are getting a value of 351 kVA and 385. Then the next step what you ask is what is the power factor and what power factor is the transformer there operating. That is VL, we know that 400 an angle of 0 degree, and IA we are getting 936.35. You can look into the phase angle between the VL and IA. It is lagging 35.2. Therefore, phi is 35.2, and cos phi is, it is transformer is operating at 0.82. Similarly, if you look into the VL and IB, it is operating at 878 an angle of 42.2 degrees, then angle phi B is 42.2 and cos B is 0.74 lag it is operating. Okay, this is how we have to solve the problem. And the last problem in this session is that the two transformer A and B are joined in parallel, once again equal ratio, unequal ratio, and is given here ZA, ZB and ZL. ZA, ZB and ZL and EA, EB is given. Straight away ask you to calculate what is the value of the current I and IB. Everything is given. Just you have to list out. EAEB is given, that is 6600 and 6400, that I am listing here. ZA, ZB and ZL also given. ZA, ZB and ZL, that is also listed. Just you have to substitute in this equation. Then the IA value what I am getting here is 195.49 an angle of 53.1 amperes. The current supplied by the transformer A. Similarly, IB, because you have to substitute all the values in this, the second equation, then you are getting 422.56 an angle of 33.59 amperes. This is how you have to solve the numericals on the parallel operation of the single phase transformer.